In this video, I'd like to look at a simple Python program that has a class. This class is going to be a hockey player, and then also use the class, so make an object of the class and use some of its, access its properties, access its methods, and so on. The code can be found at the URL seen here at the top. So again, we're going to define and use a class. A class gives us what's called encapsulation. It's going to bring things together and sort of create a unit out of it. So we're not going to have a variable. Our hockey player is going to have a first name, a last name, an ID, a player number, and then later examples, I don't know, a height, a weight, and so on. But so it's going to bring all those things together. So we're not going to have these sort of independent variables. They're all going to be brought together by the class. They're going to be encapsulated by the class. It's just bringing things together to work as a unit, to move around as a unit, to be accessed as a unit. And so that is going to give us encapsulation. So here's the sort of Wikipedia on encapsulation. It's this bundling of data and methods. So that's basically all we're going to get out of this, bring all the information and our methods about a hockey player together, not all of them, just a sort of a few simple things for an example. And it also, and we're going to, this code up here, even though it's zipped up, is only one file. I'm going to define the class and use the class in the same file, and that is unusual. Usually you would have them in separate files, because having them in separate files, another thing that you can get out of a class is reuse, that you may have more than one program that use your sort of a class, in this case, my hockey class. Therefore, then the separation of different files allows for the reuse, and then maybe multiple users working on the same project, and so on. Okay, but we're going to keep it simple, so we're going to define and use it in the same file. But again, that's unusual. Okay, so let's start here. So I am defining the hockey player class. So we use the keyword class, and then a name I make up, hockey player, and a colon. And then we have a method. For our first method is init, dunder in. So this is a double underscore. So in Visual Studio Code, it doesn't always read like it is two characters, but that's two characters, a double underscore or a dunder. And this is one of the sort of standard methods, the init method, and I'm also going to refer to it as the constructor. And I'm going to talk about this self in a minute, but my constructor is bringing in three pieces of information. I'm saying this is my template for a hockey player, and then I'm going to make a specific hockey player. I'm going to make an hockey player object, or I'll say instantiate an object, instantiate a hockey player. And to do that, I'm saying I need three pieces of information. So I'm saying I can't make a hockey player unless I know the hockey player's ID, first name, and last name. And then once I make the player, then I will refer to anytime I have my player and I want to access a property or a method associated with that player, I'm going to use the word self. So that is for sort of a self-referential to, and in other languages, the word would be this. Say if we were in Java, JavaScript, or something like that. And Python makes it a little bit more explicit. So they put in the self. You would not see that, say, in Java or JavaScript. And I'm going to show you sort of two different ways of using it. not the constructor, but the other methods, sort of with and without the self. Okay, but I'm sending to use the constructor. The self is often implied. I'll show you one time. I'll give you one example before we're done where it's not implied, but it's usually implied. And so the signature of this would be I'm sending three things. The first thing would be an ID, the second thing a first name, the last thing a last name, and then these match. So what I've called here on the right-hand side of this assignment statement matches this ID. So the first thing is called the ID, and it's called ID. Over here, I've also called it ID, and this is the name of the property of the object. This is just sort of a dummy name. I refer to it as a dummy name. The sort of whatever happens to come in, whatever the first thing, I happen to call it ID, and anything on the right-hand side matches what's coming in here. But then here on the left-hand side of the assignment statement, I am giving the HockeyPlayer object I am instantiating, I am making the properties, and these are the names of the properties once I have made them. Okay, so I can make these the same. I do not have to. This must match this, and then this is what I use anytime after I've made an object, and they can be the same, but they don't have to be. So this has to match this, but that doesn't have to match that. But when I use it, if they don't match, this is what I will use once I've created the object. Okay, so again, this is the constructor or the dunder in it, and it's got a signature of three things coming in, an ID, a first name, and a last name. And then self is like the word this in other languages and will be used to refer to if I want a property or a method of the actual object itself. That's where I use self. And in other languages, the word this sort of serves that purpose. And in encapsulation, in classes, we bring together both properties, data, and some methods. So here, just some simple methods. These are both concatenation methods, just sort of bringing together the properties. So one of my methods is the full name. This is an instance method. So that means I have to have, right now I'm making a class, just sort of a template, and then a sort of a generalized thing, and then I will make a specific thing, the object. So I will make a specific hockey player. So I have a hockey player template, that's the class, and then I will have a specific hockey player. So self means that this is an instance method, and then I must have a hockey player created. And then when I invoke this method, the parentheses will probably be empty. I'll show you that in a little bit. And what we return, what we get back from this function is just the first name and a space and a last name. So I'm just using this format to insert the first name and the last name into these two spots with a space between them. And down here for the URL, another instance method, I'm creating a URL. So the National Hockey League, the NHL, has player pages, and it's www.nhl.com/player/, and then it's the first name of the player, all in all lowercase, and a dash, and the last name in lowercase, and another dash, and then the ID. And then that is a URL that if you open that up in a browser, you will see information about the player. So those are my two methods. And again, these are instance methods, so I need to have an object, and that's opposed to a static method. So a static method means it belongs more to the template, to the class. So an example of that is if I had a math class. The math class may allow me to do sines and cosines and exponentials, or know the value of pi to a great precision. And those things, I don't have to make a math object to use the static methods of the math class. So I don't have to make a specific math object. That doesn't make sense. So I'm just getting all the functionality and properties based on just having just on the class. So the math thing is static. But for the HockeyPlayer, I'm making I want to access a specific example of the template. So so these are my HockeyPlayer. The methods are instance methods as opposed to math, which is static methods. Okay, so that is the end of the class. The end of the class. And you got to watch your indenting in Python, of course. Here I am making a class. Remember the constructor, the dunder init, had, other than self, which will be implied, had three properties, the ID and the first name and the last name. And so here's my example of creating an object, instantiating an object of the HockeyPlayer class. And I'm making this specific player, Nicolas here. And there were three properties. And the ID, I made the ID a string. Up here, it didn't specify what the types were. So it's going to do that dynamically. But here I'm sending it a string. So then ID, if I send it a string, will be a string. And I'm not going to add IDs or anything like that. So it makes sense for it to be a string. Here I am adding a property that was not explicitly seen in the class or in the constructor. So I could have properties here listed here, but I don't have this player number property listed in the class, and it's certainly not in the constructor, but I can sort of like, I don't know, assign it sort of, I don't know, I'll say ad hoc, let's just sort of bring it in. Okay, then I have some print statements. I'm just going to print the player one, and the player one is an object. And this is just going to say, oh, hey, I'm an object, and here's my memory location. So it's not going to be a very useful thing to just print an object, unless you want to know where it's located. Then I'm going to use dunder dict dictionary. So this is usually a built-in thing, and it's going to be so underscore underscore dict underscore underscore, and it's going to turn all my properties and values into a dictionary and print out the dictionary. I'm going to print out, so that was a built-in thing. I did not define that. That just sort of comes for free. Last name is a property I assigned in the constructor. Full name was a method that was defined in the class. So here's a property versus a method. So the property, there's, of course, the colors, a little bit different. But what's more important than that is the sort of parentheses. So, and a property doesn't need the parentheses. A method needs the parentheses. The full name, again, up here, had a self, but the self is implied because I am coming from player one, which is an object. So the self refers to the object, but I'm already starting off with the object, player one. And so I don't have to say the self because that would be redundant. So it's implied. And so if I'm coming from the object, I don't need anything in the parentheses, and it's understood that player one is self. And then here I'm showing you player num, and this was that sort of ad hoc property then I added. The color coding is a little bit different, but it's accessed in the same way as a last name, that it was just player one dot. I'm going to now I'm going to print out the URL method. And up here in the definition, I mean, what I'm printing out is different, but the way the function is defined is pretty much the same. Def, some name I make up, and self, or for both full name and for URL, because all the information is known to the object. But here I'm invoking it differently. I'm bringing in the function in a different way. Here I'm starting off with the class HockeyPlayer as the class, the general template. And then I'm using the URL method of that class, but it's an instance method, so we need to know the object. So then we pass the object in this way of doing it as an argument of the method. So full name here is an instance method, and URL is an instance method, and these are just different ways of calling that method, of invoking that method. One starting off with the object, and then the parentheses were empty, and the other one starting off with the class, and then an object of the class appears here in the URL. And sometimes this is a convenient way. Usually this is the more convenient way. Usually we have the object and then we want something out of the object. Occasionally this approach makes a little more sense, and they're both available to you. So you use whichever one makes more sense to you in the circumstances. Okay, now I'm going to actually use the URL. And so I'm going to bring in the web browser module, and then open up a web browser at this URL. So let's run this. Okay, and then what pops up is this web browser at that URL that we talked about. Okay, but let's look at the prints that came before that. We printed the player that was here, so we're just seeing that it's an object, it's a HockeyPlayer object, and then it's sort of here's where it's at in memory or something. So here's the dunder dict. So it created a dictionary, sort of a JSON notation, curly brackets around the whole thing, around the whole dictionary, and key value pairs, the key and the value separated by a colon, and then the pair separated by commas. And it included the player number. So it wasn't only those that were in the constructor, but all of them. Here's the last name. Here's the full name, which was a method. Here's the player number. So as far as printing out, it didn't look any different whether it was defined and in the constructor or whether it was sort of ad hoc added. They both got printed the same way. The URL got printed. And again, we invoked these two methods in different ways, but both worked and we got what we wanted. I think that's what I wanted to show you with this one. A simple class, the instance method, how to have the constructor, how to use the constructor, how to access the properties and methods of the object once we have made them. Thanks for your attention.